All right, you're here, I'm here. Let's get started. Good morning, everybody. Welcome to another wonderful morning of Chem 1105 with your host, me, Dr. White. And we're going to have a great morning. But one thing I do have to tell you, normally after labs, I spend time answering questions or talking about anything you'd like to. Today, something came up, and right after lab, I've got to leave to get something and then get back in time for my other class. So today is one of those very rare, like probably totally rare time that right after lab, I got to run away too. So please forgive me for that. On Thursday, I'll stay late and make sure if anybody has any questions, don't forget you can come to my office hour. Now, today I'm going to go really high tech on Zoom with you. I'm going to have not one, but two webcams operating. And no, I'm not going to be in stereo, so you don't have to put on those special glasses, but it'll help you learn how to use this. Now, in my class, for my test, you're going to need to use a calculator, a scientific calculator, because you will be working with scientific notation. So the question is, how do you use a calculator doing scientific notation? And let's look at an example or two or three. And the question is, how do you do this? What is it equal to? Well, notice we have two numbers, scientific notation, and then you've got to use your calculator. All right, just give me a second. It's time for mobile webcam number 2. Don't get dizzy. All right, here's your scientific calculator. First of all, I'm going to turn it on. And you'll notice right here, well, you can't see it, at the bottom, it says SCI. And that means it's in scientific notation. But what if yours is not? How do you do that? You hit the second key, and then over here, it says above SCI and some other stuff. And if you notice, well, let me do it this way. All right, you'll see FOL, SCI, and ENG. And using the arrow keys over here, you can move it. I'm already on SCI, and I'm going to press enter. Oh, by the way, if anybody gets motion sickness, don't blame me. All right, now, how do we put in a scientific number? Well, the first part of number, 1.23, you just put it in there. Now, to get scientific notation, hit the second key, then you'll see right here a double E. And when I do that, I see the letter E there. You can see I'm never going to be a hand model on TV. And now we put in our exponent. I think I had 4. And now the times key, and the second number was 3.21. And now it was, I think, 10 to the 6th. So how do we put that in? Second key, then double E, and you'll see the letter E pop up again. And now put in the number 6, if that's what I use, and I'll hit enter. And you'll see the number I got was 3.9483. Then it has a little x, a little 10, and then a bigger 10. So that's 3.9483 times 10 to the 10. All right, the key thing, to get the 10 power, after you put in the first number, you hit the second key and double E. Most calculators are just about the same. If you have a problem with your calculator, let me know. Now, what if we need to do a negative number? And like I said, the number here was 3.9483 times 10 to the 10th. That's what the calculator gave me. But as you've learned with math, you should have here, this is 3 significant figures. Oh, I'm in my rut again, 3 significant figures. So you have to round this off to 3 significant figures. Keep the 3, keep the 9, keep the 4. This is the number to round off. Is that 4 or less or 5 or higher? 5 or higher. Drop that, increase this by 1. This stays the same. So the actual answer on my test for this problem using significant figures and your calculator would be this, 3.95 times 10 to the 10th. All right, let's do the same thing. And sometimes I won't put the star there. If I ask you on a test to do this, hint, hint, for test 1, this is a skill you should have. Now, this is a little different. Notice here, instead of n, the power 10 being positive, it's negative. And how do you do that? Well, this is a source of problems students have, so watch closely. By the way, in case you're wondering, I'll show you later on. Here's my desk, my writing tablet, water, and my inner sanctum. Don't tell anybody you saw it. All right, let's go back to here. First thing I'm gonna do is clear it. I'm gonna do 3, now what I have, 1.23. Now I want to do times 10 to the 4th, second key, double E, and notice the letter E is popped up there. It's tiny, but it's there. And then 4. Now I'm going to do times, and I want 3.21. Now it's 10 to the minus 7. To get the exponent, 10 to the power, second key, double E. Now for negative, listen carefully. You do not use this key for a negative power of 10. That's the subtraction key. You use the key right here with a bracket minus bracket. And when I do that, you'll see up there, I have a minus sign after the E, and now I'll put a 7, and that's 3.12 times 10 to the minus 7. E is 10 on the calculators. And now I'll hit enter. And you'll see I got 3.948, but now I have little 10 minus 0.3 times 10 to the minus 3. So the important thing, when you're using need to do a negative power of 10, use this, whoops, this button here, not the minus sign. On the side here, under the multiplication, that's just for subtraction. The key at the bottom in the brackets right here is for power of 10 when it's negative, to make it 10 to the minus. So let's review. Make sure it's in scientific notation. Use this key and see where it says SCIENG. You click on that and you can move with your cursors right there to get it under, hit enter. Now, to put a number in scientific notation, use the keypad to put the first part of the number in. And then if it's power 10 positive, second key, double E, and then put in the number. Now, if it's negative, second key, double E right here, and then use this one, not this one, for negative. Let's do another one. Oh, let me just do one in my head. 2.00 times 10 to the fifth, second key, double E, 5, 2.0 times 10 to the fifth. Oh, let's do divide. This is divide. And you see the little line there. And then let's do 5.11 second times 10 to the minus fifth. Second key, double E, and because it's minus, I want to use this key, never that key. This is for subtraction. This is for minus. And I said 5. And you'll notice when I get it in focus, this is a pain in the... All right, you'll notice it's not in focus. There we go. 5.11 times 10 to the minus 5. Now hit enter. I get, whoa, 3.913894, 325. Then small 10, 0.9 times 10 to the 9th. And that's how you use a calculator. If you want to see my inner office, there's a project I'm working on. There's some of the stuff. Here's, I use microcomputers. Let's see if this is, you don't see the colors that well, but I programmed that to do that. Hold in there, you'll see something cool. And it switched. And how do you program that? Well, that's one of my hobbies. Probably my main hobby right now. All right. All right. I hope that was worked out for you. Listen carefully. If you still have problems with your calculator and it's not like mine, come to my office hour well before the test. And let me shut this off so you can know how to use that, because you'll need that for test 1, 2, 3, 4, and the final. So it's an important skill you should have. If you don't know how to use your calculator to do that, come to my office hour, or I'll say Thursday, not today, because I got to run away real quick. Thursday, after a lab, see me, and I'll help you. Any questions? let me ask you this. Were you able to see the calculator all right? Give me a thumbs up. Because some people haven't, or they don't want to do a thumbs up. All right, I see some people are. Thank you. And if you, like I said, if you're having problems, see me. All right, today's lab day, and henceforth, lab days are for doing problem sets, or otherwise known as discussion session, and plus the lab. Now, if we were face to face, we'd do the discussion for about 30, 40 minutes. We'd take a little break, and then we'd do the lab. I'd do my introduction and have you go out into the lab. We'd be doing this in a lab room at COD, and then you take time to do the lab. And on the way I have it set up, Tuesday, Thursday are labs. And if we started at 9 face to face, by about 10:30, if we were quarter to 11 at COD, you'd be done in the actual lab. Because I teach you all the steps. I just don't say, all right, do the lab and you're on your own, because then you're going to take all day. Because if you don't know what you're supposed to do, which is not fun, not good. So in real life, you get out early. Well, in ours, I'm not going to make you do the Beyond Labz Z lab while we're online. No, you do that after the lab today or tomorrow, as long as you get it done before the lab's due. Speaking about lab due is due, remember today the safety lab is due. I think I give you till 4 o'clock this afternoon to hand it in, upload it as a PDF file, single PDF, or you can also do a Word document to the assignment area of Blackboard. Now, what we'll be doing throughout the semester on lab days is have discussion going through the problem sets. I hope you all are working on the problem sets. They'll help you. Someone pointed out, I believe a week from this Thursday is test number 1. Relax, relax. But anyways, the way I do problem sets, I'll do one page at a time. From each problem set, I'll do some of them. If I haven't done the problem you want me to do or talk about it, ask. Also, if you have a problem with one of the problems on the problem set, you want me to spend a little extra time on that, ask. Because remember, in my class, there's no such thing ever, 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 no such thing as a dumb question. All right, let's get going. All right, thumbs up, people. Everybody see the wrong chapter. All right, chapter 1, problem set. Let me make this a little bit large. There we go. Everybody see chapter 1 on your screen. All right, thank you, thumbs up, people or person. All right, let's take a look at this. The question is number 1. And before we start, after test 1, hint, you'll understand why I call these practice problems. Hint. All right, name one of the 4 branches of physical chemistry. Organic's the best, but there's also analytical, physical, and inorganic. What's matter? Something that has mass and occupies space. Ooh, this is a good one. Remember, we practiced that. And hold on. See how the answers for these are already in Blackboard. What you're seeing right now, this PDF file, is in the answer folder of the problem set. And let me show you. That's a good question. Since you're new, you don't know. Give me time while I log into Blackboard. All right, thumbs up, people. You see Blackboard now? All right, now over here, see where it says course information? If you click on that, you have 3 folders come up. Folder 1 are the both in PDF and Word of my lectures. Not what I do on my whiteboard, but everything I put as slides are there. And if we were face to face, I'd use those in a classroom and write on a whiteboard. You see another folder, recommended problem sets. And finally, there's recommended problem set answers. And if I click on that, which I just did, you'll see practice problems chapter 1, which is what you're seeing on the screen. So the answer is yes, it is available. And if you can't find something like your colleague just did to everybody else, ask questions. That's why I keep on saying there's no such thing as a dumb question. Because if you don't know something, ask a question, you'll find out. All right, let's get back to our problem set. Like I said, this is in that folder as a PDF file. Now, what are the 3 states of matter? They are, and everybody, if you want to say it along with me, you can, solid, liquid, gas. And I don't have it here, but you should know a solid has definite shape, definite volume. A liquid has indefinite shape, definite volume, and a gas has indefinite shape, indefinite volume. Now, we talked about pure substances, and one of the things I like to do in any course I teach, and also real life, I think about it, where do we use this stuff where are they in our everyday life? So if I ask, name a pure substance that you could use in your daily life, and I use formulas, but you could have written it out. Water is one, gold is one, another one is oxygen gas, sodium metal would be pure. So those are a lot of things. Now name a mixture that you could purchase at your local grocery store. And there are a lot of things, but milk is a mixture. If you get mouthwash at your local grocery store, I guess if you call Walmart a grocery store, well, the one by my house sells mouthwash. That's where I get mine. And mustard and pop. By the way, Dr. White is from the Chicagoland area, except for 5 years when I lived in Michigan, going to Michigan State for my PhD. And being from Chicagoland, the stuff in a plastic bottle or metal can that's carbonated, non-alcoholic, we call pop, not soda. And there are many others you could put in there. You could put tea, coffee down there. What would be another good one? More good one. Oh, strawberry jam is a mixture, or jelly is actually a mixture. That's a good one. Or something I don't need, pancake syrup. All right. Now, oil vinaigrette salad dressing, is it homogeneous or heterogeneous? Remember, oil vinaigrette separates into 2 layers, therefore it's heterogeneous. Is gasoline homogeneous or heterogeneous? Well, if you take a sample of gasoline, do not try this at home, and put it in a container, you'll see it looks the same, and it better look the same throughout. So it's homogeneous. Now, give the chemical symbol for the following: carbon C, chlorine Cl. Ooh, my favorite, gold AU, oxygen O, and sodium is a good one too, Na. You should know the 37, I believe it is, on the list I gave you. And then the other thing you should know is give the name for the chemical symbol, Na sodium, Br bromine, my favorite, C carbon, magnesium Mg, gold, argon, Kr, krypton. Remember, krypton in our world, unless I've been kidnapped to another universe, is a colorless gas at room temperature, not a green solid that kills Superman. All right, next we talked about physical properties, And the question is, water freezes at 0 degrees C. What, is that a chemical or physical property? And the answer is it's a physical property. It's not how it changes chemically, but how it goes from one state to another. In this case, from a liquid to a solid, and that's a physical property. Oxygen is a gas at room temperature. That's a physical property. Oh, I think I have two of the same. Oops. Iron can rust. That's a chemical property. Gasoline is flammable. And give an example of a physical change: water boiling, ice melting, sodium chloride dissolving, because the salt, sodium chloride, still exists in water. And finally, give an example of a chemical change. I don't know if I told you, most organic chemists who are good when they're young were pyromaniacs. I'm no different. A candle burning. Also, when you eat food and it's in your stomach, digesting, it's undergoing a chemical change, and iron rusting is undergoing a chemical change. And that's everything from chapter 1. Any questions? All right, well, in that case, let's move on to Appendix A2 and A4. Now, one of the things we talked about, notice how I say we, I talked about, you listen, is, sounds more nice when I say we, uh, how do you write the following numbers in scientific notation? Well, let me blow this up a little more so you can see it better. If we look at the following, the A, where there was a decimal point, if there was, which there isn't, you move it to the right of the first non-zero number. And I do it that way. And how many times did I move it? 1, 2, 3, 4, 5. So when there's no decimal, zeros at the end are dropped. And so that'll be 6.252 times 10 to the nth. I moved it 5 times, so n is 5. Now, if we look at D, when the number, well, first of all, for A and B and C, when the number is greater than 10, 10 to the n, n is always positive. When the number is greater than 10, 10 to the n is always positive. So if we look at B, if the decimal point were here, I move it 1, 2, 3. That's a comma. And that'd be 1.23. How many times did I move it? 3 times 10 to the third. Why is this positive? Because this number is greater than 10. Now, when the number is less than 10, or that, let me back up. Nope, I just backed the tape up. When the number is less than 1, you still move the decimal to the right of the first non-zero number. All lead zeros are dropped. And n is a minus number. So we move this to the right of 5, 5.67. And then how many times do we move it? 1, 2, 3. But since this number is less than 1, that's 10 to the minus 3. And if we look at F, same thing. This number is less than 1. Move this decimal point to the right of the first non-zero number. That would be 3. So it'd be 3.33. Lead zeros are dropped. And we moved it 1, 2 times. Since it's less than 1, it's 10 to the minus power, in this case, minus 2. You know something? I've got to share some of the fun with you people. Why don't you write that in scientific notation? 45000. All right, I think everybody's done. If there were a decimal, which there's not, it would be here. And you move it to the right of the first non-zero number, 4. I'm going to move it 1, 2, 3, 4. These zeros I'll drop because it's at the end without a decimal. Remember, I put that in there just to help me count how many times I moved it. So 4.5, the number is greater than 10. Remember, this means greater than. And I moved it 1, 2, 3, 4. And therefore, n is positive 10 to the 4th. And that's how you do it. Ah, you're right, Lily. And that's how, oh, let's do another one. Why don't you do this one? And yes, there is a decimal point there. Write that in scientific notation, 3 points each. And when you're done, give me a thumbs up. All right, let's try something different. All right, looks like everybody's done, so I better get to work. Notice this number is less than 1. When it's less than 1, n is negative. And I'm talking about n is 10 to the power n in scientific notation. So I move the decimal to the right of the first non-zero number, 1, 2, 3, 4, 5, 6. So I get 7.31 times 10. I moved it 6 times, but since this is less than 1, n is negative 10 to the minus 6. And that's how you do it. I'd highly recommend, if you haven't done the practice problems on your own, do some of them. All right, listen up carefully. I didn't take it out because I decided this semester we almost never go from scientific to decimal. Therefore, just put an X through 2. You don't have to know how to do that in my class anymore, because realistically, you're going to be on a calculator and you don't know, you don't have to put it from scientific to decimal. I rarely do it. It was in the book originally and I should take it out. All right, next, number 3. How many significant figures are in the following numbers? And here, what do? All non-zero numbers are significant. So A has 1, 2, 3, 4, 5. Zeros at the end without a decimal are not. All non-zero numbers are. So in B, I have 8, 7, and 4. That's 3. But the 0 at the end, there's no decimals, not, which is why they're 3. Now, if we look at C, 0 confined by non-zero numbers, zeros in between non-zero numbers are significant. Non-zero numbers are significant. The ones are, and the 0 is, so that's 1, 2, 3. Now, when you're doing scientific notation, you ignore 10 to the minus whatever, 10 to the plus whatever. And therefore, D 4 non-zero numbers, 4 significant figures. And if we look at E, lead zeros are never significant. So this has 3 non-zero numbers. The lead zeros are not significant, so that's 3. Zeros at the end with a decimal point are significant. Non-zero numbers are. So I have a 3 and a 2 plus 3 more zeros makes 5 significant figures. Now, gee, I got real fancy on you. Look out. Non-zero numbers are significant. So the 3 ones are significant. Zeros that are combined, this 0 and this 0 are significant. So it's 2 more, but a 0 at the end without a decimal point are not significant. So that would be 5. I was going to do H, and thank you for asking your question, because now I know I better do it. All right, let's look at H. If we look at H, there's a decimal point. Zeros after a decimal are significant. So I have 2 non-zero numbers, which are always significant, and this 0 after the decimal point is also significant, which is why the number is 3 significant figures. And why don't you do the following? Hold on, let me check chat. You're welcome. Remember, all questions are good questions. How many significant figures are in this number? All right, let's do it. All non-zero numbers are significant. This is. Notice no decimal point. Oh, I just made up a new abbreviation, DT, decimal. No, I was right the first time, DP, decimal point. And zeros at the end with no decimal are not significant. So this would have 3 significant figures. Why don't you do this one? How many significant figures in B? Time's up. Let's take a look. All non-zero numbers are significant. Zeros that are confined in between 2 non-zero are always significant too. So this would have 4 significant figures. How many significant figures in this number? 2.500 times 10 to the 8th. And just so you can see it, there's the decimal point. And I think everybody's done. So let's take a look at this. All non-zero numbers are significant. There's a decimal point. Zeros at the end after a decimal point are significant. So this would be 1, 2, 3, 4. And the answer is 4 significant figures. Let's do 2 more. How many significant figures are in that number? I'm glad to see all of you are catching on. Just think, 3 months ago, if I asked you this, would you know what I'm talking about? Think how much you've learned in our short time together. Doesn't that feel good? I hope it does. All right, let's do this. There's a decimal point. Non-zero numbers always significant. Zeros that are lead zeros are not. So this would have two significant figures. Let's do one more. 0.00310. How many significant figures are in there? Oh, look, the answers are coming in, and let's find out if you're right. Hope you are. All right, notice we have a decimal point. Lead zeros are never significant. All non-zero numbers are. Zeros at the end of a number with a decimal point are. So this would be 1, 2, 3, and the answer is 3 significant figures. And that's how you do significant figures. Now, next one, as you saw at my calculator earlier, you have to learn how to round off things. And if you notice, Dr. White, oh, wait a second. After the break, I'll have a show and tell for you. Did anybody warn you Dr. White does show and tell? When I was in grade school, my teachers were always scared of show and tell when I was in the class, only because I'd bring in things that were highly scientific that they had no idea what I was talking about, and they didn't like that. English teacher that I taught about plane polarized light was quite upset with me. But anyways, back to chemistry, and how do you round it off? You keep the numbers you want, and the first one after that significant used to round off. Now, for these, I have some here, but in all reality, A is the most important. How do you round that off to 3 significant figures? Keep the 1, keep the 5, keep the 5. Use the second 5 to round off. Is that 4 or less or 5 or higher? 5 or higher, drop it, and 1 in front, you increase by 1. Now, in real life, in my class, next ones, I've got to rewrite this. I would never do, so I better have you practice a couple rounding off on your own. Round that one off to 4 significant figures. Oh, let's do a 2 for Tuesday. And do B, I'll let you do both, and then I'll give you the answers. All right, let's do the first one. For rounding off the 4 significant figures, keep the first non-zero number. Second, third, fourth. This is the number we use to round off. Is that 4 or less or 5 or higher? 5 or higher. So that and everything else I'll drop. And this becomes 7.134. Let's do B. Keep the 8. Keep the 3, keep the 3, keep the 3. That's my 4 significant figures. The next one I use to round off. Is that 4 or higher? I mean, 4 or less, or 5 or higher, and 5 or higher. So I'm going to drop this, and the number in front I increase by 1. And that's how you do rounding off. And for this class, because we're going to be using scientific notation, this is essentially the way you'll be rounding off. Now, why do you round off? Well, you saw my calculator give me all those interesting numbers. Now here I have this, and I really should have done it in scientific notation. And let's look at C. Remember, when you multiply and divide, you get the same number of significant figures as the number you're multiplying or dividing that has the fewest significant figures. If you look at C, the first number has 3 significant figures. The second one has 3. My calculator gives me this large number here, not large, highly significant, but how do you round that off to 3? Keep the 6, keep the 0, keep the 5, use the 1 to round off. 4 or less, I drop that, and I get 6.05 times 10 to the 12, 3 significant figures. Now, let's look at E. And here, I'm multiplying again to these two numbers. And if we look at the first one, it has 1, 2, 3, 4. This is a mistake. 5. This is a mistake too, so I'll rewrite the right number. The second one has 6, so my number of significant figures should be 5. And if I take 6.2713 times 10 to the 6th, how do you round that off to 5 significant figures? I'll let you try that first. All right. And the answer is keep the 6, keep the 2, keep the 7, keep the 1, keep the 3, drop the 2 because that's the 1 to round off. So the correct answer really should be here, 6.2713. Dr. White made a mistake. I do that. At least I try and catch it. And for division, you do the same thing. Let's look at H. I have this number divided by this. First you have to do is figure out sign how many significant figures, excuse me. And the top one has, let's check if I made a mistake, 2, 4, 6. Oh, I got that one right. And the bottom, 4.8 times 10 to the minus 4th, 2 significant figures. By the way, SF is shorthand for significant figures. When you multiply and divide, you get the same number of significant figures in your answer that the number that has the fewest significant figures you're using in your calculation. And this case is 2. So the number 1.5722 times 10 to the 9th, you have to round off to 2 significant figures, keep the 1, keep the 5, use the 7 to round off, 5 or higher, I'll drop that and everything else, and the number in front I'll increase by 1. Now for addition, you get the same number of significant figures as the number that has the fewest significant figures to the right of the decimal point. Everything to the left, you don't change, you just do the addition. And if we look at B, the first number has 3 to the right of the decimal significant figure. The second one's 2, so I round this off to 2 pass, keep the 9, keep the 1. 6 is 5 or higher, drop that, and change the 1 to 2. And that's how you do it. All right, any questions? I noticed I wanted to finish, so I've gone a whole 2 minutes past the normal break time. You will forgive me, won't you? Please. But anyways, let's take a break. First of all, let me ask, are there any questions? I'm looking at the chat pop up. Nothing popped up. All right. What time is it? Why don't you come back at 9:57? Take 5 minutes. 9:57. That's when the big hand is over here. But if you have a digital watch, which most of you do, when it says 9 colon or semicolon 57, I'll see you in 5. Time to start again. Everybody back? I see everybody giving me a thumbs up, so let's get going. All right. Today's lab deals with the first time with the lab simulation Beyond Labz. And I always say that, I don't know why. But anyways, it works. It's a very good product. Last semester was the first semester we used that. I used it, and the department used it for different chemistry classes. And it works well, and it's fun, and you'll see. Now, before I go ahead, if you haven't received your activation code, and sometimes if you bought your activation code from the COD library, last semester they were slow with a couple of my students, let me know. And what I'll do is have you work with me on that during my office hour on Wednesday. That way you can handle the lab. Speaking about handle labs, don't forget the safety lab is due today. And for those whoever emailed me, I haven't read it yet. Even though I checked it this morning, if it was after 5:30 this morning, I haven't checked it since. Yes, I start early sometimes. I was on email by 5:30 this morning. It's a habit I've had all my life, getting up early. One company, I used to actually start work at 5:30 in the morning. They let me do that because that way people in Europe could call me for help because it was an international company. Also got to go home early too. But anyways, if you have problems, let me know and we'll work it out. It happens. All right, now, how do you do Beyond Labz? Now, I already have the login page. Well, let me show you if you haven't figured out. Everybody see Google on their screen? Hold on. Everybody give me a thumbs up if you see Google and Beyond Labz on your screen. Thank you. Go to Google in case you don't know the link, put in Beyond Labz and the first hit, and you can click on where it says login. And this is a screen you have. Now, before that, let's go back. If you click on Beyond Labz, this is what you'll have. And you can see login is up here. If you need support, click on this, and they're pretty good about giving you help. If you have any problem, click on support and ask them. If they don't give you an answer, let me know, because I'm working with some of their people. I know them quite well, and I'll follow up with them and get an answer for you. These people are really good in getting back to help students. And no, I don't want to sign up for your, well, actually I did. But anyways, if you click on login, you get to here. And I'm going to put my email in. You put yours in. If I can type. And notice you have installation setup. The first time after I set up and I came back, I was confused. But if you haven't set it up, you do the download here and you do the physical chem and the chemistry. And right now I'm going to connect. I think I have a question here. Okay. And you'll see on here, labs and activities. Now, for the first lab is going to be in physical science. And you click on open. And I forgot to say at the bottom, And we're going to do density, and let me make sure you can see this now. Thumbs up, people. Do you see density in the upper right-hand corner or left-hand corner of your screen? Anybody see it on your? Thank you. All right, now, before we go into that, let's talk about today's lab. Everybody see density lab on your screen? Thumbs up, people. Well, you people are slow this morning. Thank you. All right. Now, this you can download from the assignment area of Blackboard. Again, you can download it both as a Word file and as PDF. And today, you're gonna learn about density. Now, listen carefully. Things I do in the lab and teach you will never be in the test unless I also lecture about it in lecture. If I don't lecture about something we learn in the lab, it won't be on a test. And density is never on a test, but it's an important physical property of matter. By definition is density is weight per volume, which I'm going to call Formula 1. And to determine the density of an item, you measure the weight of that item and you measure the volume. Then you divide weight by volume to get the density. Now, in chemistry, weight we measure in grams. Volume we measure in milliliters. Therefore, density is grams per milliliter. That's the most awful looking M. Let's try this again. That's better. That's G per ml. ml is milliliters, G is grams. And important aspect of density is lower density substances float in higher density substances, and higher density substances sink in lower density substances. And water has a density of 1.00. And if you put a piece of cork on in a bucket of water, cork has a density much less than 1. The cork floats, which is why many, many years ago, the life preservers were made out of cork with some fabric around it. You know, the kind you see in the old movies they threw to someone who fell off a ship that looks like a big donut. Now, something higher density than water will sink in a bucket of water. If you had a cannonball made out of lead and put it in a bucket or a barrel of water, it goes whoop all the way down. So lighter things float in density that's heavier than the object, and higher density things sink in lower density liquids. And you'll be using a graduated cylinder to measure volume. And I'll show you in Beyond Labz. Well, let's watch this video. Do we have time? Sure we do.
We're going to learn how to measure liquids accurately and precisely.
Everybody see the YouTube on your screen now?
It's very important when you measure any type of liquid, you use a graduated cylinder like these. You do not want to use a beaker or a flask because those aren't calibrated to measure liquids accurately. So stay away from beakers and flasks. I know they have hash marks on them, but those aren't as accurate and precise as a graduated cylinder. Those are just general estimations. So if we look at our two graduated cylinders here, we have a large one and we have a small one. Each one is different. So it's always important to pay attention to what type of graduated cylinder you have. So the hashes for each one can be different. So if we look at the large one on the right, the larger hashes are 1 milliliter markings and the 0.5 milliliter markings are smaller hashes. So that's for a larger graduated cylinder. And if we look on the left, we have a different hash system. So the larger lines are 1 milliliter markings, but the smaller ones are now 0.2 milliliter markings. So when you take measurements, you want to take it to the 10th place. So for example, 8.5 milliliters would be a good reading rather than just 8 milliliters or 8.52 milliliters. So if we fill both of these graduated cylinders up, let's try to take an accurate measurement of the two liquids. Okay, so if you look at the hand on the screen, now my little pointer, let's try to measure out the volume on the smaller graduated cylinder. So if we look here, this line here is a 7 milliliter mark. So if you remember, these little hashes are 0.2 milliliter marks. So this is 7, 7.2, 7.4, right? The meniscus looks like it falls underneath the 7.4. So you could say an accurate reading would be 7.3 milliliters. Okay. Now, if you said 7.4, that's not bad. Okay, that's acceptable. So now let's look at the graduated cylinder on the right. Here we have 15 milliliters. And if you remember, these hashes, right, they're hidden here. Each one represents 1 milliliter. So if this is 15, this one is 16, there would be one that's here 17, 18, 19, 20, right? And if you remember, the ones in the middle are 0.5. So if this is 15, this is 15.5, then this would be 16. And from 16, this is 16.5. And up here would be 17. So it's very difficult to see a meniscus here, but it should fall somewhere within this range. So if this is 15, this is 16, and then 17 is right here, you can probably say the meniscus is somewhere in here, right? It's a little difficult to see. You can kind of see a little bit over here. Now you can say an accurate reading for this would be, if this is 16, this is 16.5, maybe somewhere around 16.8, because the meniscus is definitely under the 17 milliliter mark. So 16.8, 16.9 milliliters would be a good reading for the graduated cylinder on the right.
Now, one of the things that video showed us is the meniscus. And in case you're not familiar with the meniscus, and oh, warning, Dr. White's going to do some artwork, so don't laugh too hard. If we have a graduated cylinder, it's got a base, and you have markings here. Think of a graduated cylinder as a very, very accurate measuring cup. Now, when you put in a liquid in here, it forms a U. This is called the meniscus, and I'll never ask you that. And you measure the volume at the bottom of the U right there, whatever line it is. Now, it depends which graduated cylinder, how accurate and what those lines are. And in today's lab, you're going to measure volume and weight, and I'll show you this. Now, how do you measure the volume of liquid? Well, you pour it in a graduated cylinder. How do you measure the volume of a solid? Use what's called water displacement. And I'll let you watch that on your own. How many of you have ever gotten into a bathtub and you see the water level rise. And the difference from where it was and where it rises to is the volume of you. And that's how people can be measured for their volume. And you can find out the density of a person if you know their volume and weight. Well, we're not going to use a bathtub. We're going to use a graduated cylinder. And for this lab, you'll use the density lab in the physical science choice of Beyond Labz. Now, I have here procedures. Now, I might not, I'll have to look. If I didn't, I'll have to post it later today. Beyond Labz has their labs in PDF files. In case you'd like to look at it, you don't really have to read it because I've rewritten them all, so it's easier for you to follow. And there's going to be two parts, actually more than two parts. In part one, you're going to do density of a liquid. You're going to weigh it or measure the volume, then weigh it and do the math later on. And we have a series of liquids, and I'll show you in a second. Plus, to make it interesting, we have two unknown fluids or liquids. And if your last name begins with A through L, you use virtual liquid fluid A. And if your name starts M through Z, use virtual fluid, which is a liquid D. And therefore, you only have to fill out one of these two. Notice I have the weight, the volume, and this you calculate by weight divided by volume. Now, you'll also do density of solids. And here, you'll weigh the solid and record it. And then in a graduated cylinder, you'll put some water. I'm going to go through this in Beyond Labz, so you'll see how to actually do this. And record that initial volume. Then you'll take the solid from the balance, put it over a graduated cylinder, and drop it. And after it drops, the liquid, water and that will rise. And that's your new volume. And the difference of the larger minus the smaller number is the volume of that solid. Oh, look at this. Density, weight, divided by final volume minus initial volume. And here I have a table for you to do certain ones. Then we have two unknowns. That makes it more exciting. And virtual B, solid. If your last name begins A through L, that's the one you use. And if your last name begins M through Z, do virtual solid C. Now, you've done one virtual liquid and one virtual solid. And to make it interesting, the DuPage County District Attorney needs to know the identity of the unknown liquid and solid, otherwise known as virtual liquid and virtual solid, in order to convict the person of a heinous crime. I'll let you fill in the blank for what heinous crime. And you must determine the identity of the unknown solid liquid in table 1 and 2 by determining the identity or the density of the unknown liquid and solid, and thereby helping the DuPage County District Attorney convict that person of a heinous crime. I'll let you fill in what heinous crime you want him to be or her to be convicted of. Now, listen carefully. The density in table 4 will help you determine the identity of the unknown liquid and solid in table 1 and 2, which you'll do in table 3. What that means is this liquid and this solid, depending on which letter you use by your last name, you copy the density and put in the identity. Those are only found in this table. Don't go to the internet, use this table. I'll say it again. The identity of your unknowns, liquid and solid, are found in this table. And then we've got some questions for you to do at the end. All right, let's look at how do we do Beyond Labz. Once you click on physical science, notice they have middle school and high school. make sure this is highlighted before you open it. That takes you to high school density. When you do that, you'll now see this screen. Thumbs up, people. Everybody see density in upper left hand? Thank you. Click on that. And they got sound effects. Here is the lab. Now, here are your graduated cylinders. Here's your balance. Now, the word tare is used in chemistry to zero it. Now, first of all, let's do water. And notice you have over in the left arrows that you can go like this, alcohol, or go the other way. And notice I have water now. I want to fill the graduated cylinder all the way to the top. Aren't those sound effects cool? Anyways, Dr. White is having a good time. Take the beaker with your mouse and put it on the balance. This is called a top loader balance. And click tare. Now, before we pour the liquid in there, if you click on the balance on the graduated cylinder, notice up here, you'll have a magnified view, and there's the meniscus. And this one is hard to read. Each one of these lines is 2 milliliters. Notice from 230 to 250, there are 10 lines. So this one is 232, 34, 36, 38. This larger line is 240, 242, and so on. And this is right about, it's hard, but it's the line right below 230. And I'll call that 228.0 because it's right on the line. Remember, the meniscus is the bottom of this U, the liquid. So that would be 229, we'll call it. And that's the volume you'd record. Now, here's the fun part. Put your cursor over the graduated cylinder, click on it, left click, and now, is that wicked? I love it. Notice the weight is 229.346. It will bounce around 0.385, and just pick one of them. Use all numbers. Notice this is 6 significant figures. Your graduated cylinder is 3. If you divide one by the other, what do you think the weight should be, or the density? 3 significant figures for this one. Now, when you're done, take this and hold it over there, let go. It pours it back in. Now, to get rid of it, see the little blue knob down here, lever, click on it. It's like flushing a toilet. And you're ready for the next one. And you'll see up here by moving it, you can go to different liquids, and you'll have to find. Use the full, don't use half full. Make sure this is on full, not like that. And then let's find another one. I think alcohol is one. And you can move, you can keep it here, you can move, this arrow moves this over to different graduated cylinders really. And you click on fill, and there you go. Measure the volume, measure the weight. And that's how you do liquids. Now, let me flush this. Let's get back to water. I always go the wrong way. All right, now up here are your different solids. If you hold your cursor over it, it tells you what it is. Let's try nickel. I don't know if that's one you're going to do, but take it. And before we do that, make sure now with a solid also, before you put anything on it, is the balance is tiered. Click right, left mouse, click on the button that says tear. And now we're going to take nickel and we put it over there. And notice the weight, which you will record for the solid, if we were doing nickel, 170.166. It will bounce around. In real life, if somebody walks by or air currents can cause that to happen. Now, next, before we put this and measure the volume, you will fill the graduated cylinder, and here you use water. Now I'll measure the volume of water. And again, this looks like, now it looks like 228. And now the fun part, take the ball, the solid, put it right above, let go, see how it's in there? And then click on drop. 1, 5, 4, 3, 2, 1, go. And now notice the volume has increased over here. Now it's, if I read it right, that's 244. I could do 244.0. Let's just call it 244. And that's the volume. And the weight divided by the difference of 244 minus, what did I say, 229 or 228, that would be the volume of that ball. Now, when you're ready for the next one, same thing, blue knob, watch what happens. Now, this is the one you're not going to be doing for the lab, but let's have some fun. Chemistry style. Got water. I'm going to take sodium. Now, sodium, don't weigh it. This is just for fun. So everybody watching, we're going to have some fun. Water and sodium don't mix. It gets hot and it blows up. So if you want now to fix it, uh-oh, I broke it. You can exit and come back in, or just go to another graduated cylinder. Uh-oh, I locked her up. I don't know why that happened, but anyways, that's today's lab. That's weird. Yeah. And that's today's lab. You'll go through, and let me open this up. For the first part, I showed you how to do the liquids. You'll take alcohol, weigh it, or measure the volume, then weigh it on the balance in the beaker and calculate the density. Same thing for corn syrup, mercury, and the one of these two virtual fluids, depending on your last name. And here for the second part, and I have it step by step what I just showed you, you'll measure, like for gold, you'll weigh it. Remember, tear the balance. Who's ever got a question, I'll get to you in a second. You'll put water in the graduated cylinder, measure the initial volume, then drop the gold in there, the ball of gold, and measure the final volume. And for this, the density is weight of solid divided by final volume minus initial volume. And that's today's lab, plus answering the questions. Don't forget, this lab is due on Thursday. All right, someone just asked where the virtual solids. Let's see if I can get this working again. All right, let's do this. Let's open this again. Let's go to density. I'll explain how to find due dates in a second. All right, let me make sure you can see this. All right, everybody see the lab again with the graduated cylinders? Thumbs up, people. Thank you. Now, if you look over here in the lower, this part is in alphabetical order, the solids, until you get here. Here's virtual solid A, B, C, and D. Now, you got to do the arrow. I forgot it's up or down to get to the virtual liquids. You keep on clicking on this one way or the other. See, near the end, after water, there's virtual solid D, which is quite dark. There's C, the liquid. I don't know which ones I asked you, but there are 4 of them. I think I have which ones. Oh, that's a pretty color. That's just wicked. If I put it in here, if you haven't figured out, my favorite color is red. When, by the way, orientation when you're is important. Notice I put the beaker in front and it clicks in place. And I'm going to flush this away. Now the exit works. I don't know why it froze earlier. If something like that freezes, just close the screen and open up again. And now exit this. Don't forget to log off. Now, one of your colleagues just asked, all right, hang in there. I'm going to go to student view. All right, thumbs up, people. You see the announcements on your screen for Blackboard? Click on assignments. And if we say click on density lab, when I clicked on the density lab, does everybody see due date on there? That's how you find out. Now, in case you don't want to do this, it's real simple. Every lab is due the next lab period after we do it. Therefore, today's lab is due Thursday. The lab will do this Thursday is due next Tuesday. So the lab is always due on the next lab period. But in case you forgot, open up the assignment, click on that. Let's go back and do it again. Where it says assignments, let's do the safety lab. Click on that, left mouse click, and right on top it says due date, which is today. And you got until 5 p.m. to get the safety lab in. Aren't you glad your instructor is a power user? All right, listen carefully. For those who haven't done it, get the signature sheet uploaded to the assignment area as soon as possible. If I don't have it in by the time you get the first test next Thursday, you get 0 points for test number 1, and that can't be dropped. That's going to hurt your grade. I need that signed and uploaded as either a Word or a PDF file. And with that, I'm done. Remember, I said I have to run away, get something done right now. So normally I'd stick around for questions, but today I don't. But remember, come to my office hour tomorrow night or email me or this Thursday, I will stick around as long, or at least so for at least 10, 20 minutes, because I also have to teach at 1 on Thursday at the other school. With that, I hope you enjoyed today's morning, and I hope you have fun with Beyond Lab Lab Z. And Jada, if you hang around for 30 seconds, I'll check. With that, I'll say, gang gesund, be healthy. Goodbye. By the way, I stole this from Granny from the Beverly Hillbillies TV show.
Thank you. Bye.
Goodbye.
Good day.
Thank you.
You're welcome. Jada, I'll do this real quick. Let me exit this. All right, Jada, I just saw did it just get hung up when you can turn your mic on. Did it get hung
Okay.
up when you tried to install it and didn't go any?
No, it's actually been like that for the past 2 days. I don't know, maybe if it's something on my end.
What kind of PC are you using? Or
HP.
a PC as opposed to a Mac, right?
Yes.
What I would do is just close that window,
Okay.
log off, and try installing again.
Okay.
Now,
Thank you.
before you run away, do you have the product called CCleaner?
No.
All right, it's a free download. Let me show you this. Every PC, I've been using this product for many years. Do you see it on your screen now? CCleaner free.
Yes.
This is a download. Just put in CCleaner in Google and
Okay.
don't buy the paid one. Get the free one. I've been using this product for years, and notice it cleans off. If I click on Analyze, you want to run Cleaner. This cleans up a lot of junk from your computers that doesn't get cleaned up.
Okay.
But before you do this, just try and redo this again. Now, I'm not going to close Firefox, otherwise we're going to get logged off. So I'll click on No. But notice all the files it would delete here. Can you see that?
Mm-hmm.
And sometimes some of these files interfere with other things you're doing.
Okay.
And I've been using this product. Every time I log off using the internet, I run this every time. And I have 3 computers, and each one has a copy on there. It's free. But before you get CCleaner, what I'd highly recommend you do is just close that window. Let me do this. Close that window and just log off and open it up again and try the install. Now,
Got it.
there's another way where you can go into the folders on your hard drive where Beyond Labz is and delete those, but try just the simple way first.
Okay.
And
Thank you so much.
And if you can't get it to work, let me know and I'll help you out. Or
Okay, because this is a way new computer. I've never used this before, so I don't know what's the problem.
all right, I don't either, but when all else fails, close it and redo it again is the first thing. The other thing
Okay.
you also might want to do is reboot your computer first.
Okay.
In other words,
Thank
shut
you
down.
again.
Yeah, and we'll see what happens. With a PC, there's sometimes some hiccups, but other than that, I'll help you get through it. So at least you got
The
that.
I'm sorry. HP computer is it PC?
Yep, there's
Oh,
two types
okay.
of computer system. You've got Windows 10 on your computer, right?
Yes.
There's either Windows or Mac. And you've
Okay.
got a Windows, my computers are Windows. My sister is a Mac person. She hates Windows. I hate Mac. This is a personal preference. The fact that you got that screen on there tells me at least your access code works.
Okay. Thank you.
All right, you're welcome. With that, anybody
I-
else a real quick question, or I'll say goodbye because I got to run.